Hi there, and welcome to this lesson on Pure Mathematics 2. And in this lesson, we're on Chapter 2, 2.3, and we're looking at the intersections of straight lines and circles. So how do we find the intersection points of a circle and a straight line? Well, the method is exactly the same as for finding the intersection points between any curve and a straight line. Usually the best thing to do is to substitute for y from the equation of the straight line into the equation of the circle. When we do that, we'll end up with a quadratic in x. And in terms of the determinant of that quadratic we obtain, geometrically, the situation is very similar to previous work we have done with the curves of quadratic equations. And we'll just quickly remind ourselves of that. So if you have a normal quadratic curve, if the determinant is greater than 0, if b squared minus 4ac is greater than 0, the curve intersects the x-axis twice. So you get two distinct solutions, two distinct routes, and the curve cuts the x-axis in two places. If the discriminant is equal to 0, then the curve touches the x-axis at one point, and you get something like that, and you get repeated solutions or repeated routes for the equation. And if the determinant is negative, then the curve doesn't touch the x-axis at all, and you would get something that looks a bit like that. Now, if we're considering the quadratic we get when we're trying to find the intersection of a line and a circle, something very similar happens. So for the resulting quadratic in x, if b squared minus 4ac is greater than 0, then the line intersects the circle at two distinct points, and you get something that looks a little bit like that. If the discriminant is equal to 0, then the line will touch the circle at one point, and you will get something a little bit like that. And if the discriminant is negative, if it's less than 0, then the line does not touch the circle, it doesn't intersect the circle at all, and you get something like that. Okay, let's have a look at an example doing all of this. Find where the line y equals x plus 2 intersects the circle x squared plus y minus 3 squared equals 13. Now what I'll be doing is I'll be substituting y equals x plus 2 into the equation for the circle. So here, instead of writing y, I'll be substituting in x plus 2. Multiply out the brackets, I'll get a quadratic. Solve the quadratic, and you will find the intersection points. Okay, I'll let you have a go at doing all of that yourself. So pause the video, see if you can make sense of this, and then come back to me when you're ready. Okay, let's have a look. So that's the equation of the circle. And what I'm going to do is substitute y from the straight line into the circle. So the circle becomes x squared plus x plus 2 minus 3 squared equals 13 when I substitute in for y. Then I need to square the brackets. Well, first of all, that bracket does simplify to x minus 1 squared, but then I'll square them. That gives me x squared plus x squared minus 2x plus 1 is 13. Tidying all of that up gives me the quadratic 2x squared minus 2x minus 12 equals 0. Now to find the intersection points of the line in a circle, I need to solve this quadratic. First thing to do is just divide by 2 to simplify it. That'll give me x squared minus x minus 6 equals 0. And this does factorize into two brackets. So I'll get x minus 3 times x plus 2 equals 0, which gives me two solutions for x. Either x is 3 from the first bracket, or x equals minus 2 from the second bracket. Looking at the first solution, when x equals 3, to find y, the easiest thing to do is to go back to the equation of the line, which tells us that y is equal to x plus 2. So when x is 3, y equals 3 plus 2, which means y equals 5. And then similarly, when x equals minus 2, going back to the equation of the line again, y equals minus 2 plus 2, which means that y is equal to 0. Therefore, the line intersects the circle at the coordinates we've just found. So x equals 3, y equals 5, and x equals minus 2, y equals 0. Example 2. Show that the line y equals x minus 3 does not intersect the circle. X minus 2 squared plus y plus 4 squared equals 4. Now, the beginning of the method will be exactly the same as before. So we'll substitute from the line into the circle. So y equals x minus 3, I'll substitute in there. Tidy up terms, multiply out the brackets, get a quadratic equation to solve. Now, if all I've got to do is prove that the line never touches the circle, never intersects it, all I have to do is find the discriminant of that quadratic, b squared minus 4ac, and show that it's negative. And if that's the case, the line doesn't intersect the circle. Okay, I'll let you have a go at doing that yourself. So pause the video, see if you can work your way through this, and then come back to me when you're ready. Okay, let's have a look. So we begin by substituting y equals x minus 3 into the circle, and that gives us x minus 2 squared plus x minus 3 plus 4 squared equals 4. Tidying up this bracket here gives me x plus 1. Then multiplying out both brackets, squaring them both will give me all of that. Collecting up the terms on the left-hand side gives me that, and then finally moving the 4 across gives me 2x squared minus 2x plus 1 equals 0 for a quadratic equation. And I have to solve this equation if I'm going to find any intersection points, but the question tells me that the line doesn't intersect the circle. And it tells me, asks me to prove that. All I have to do is find the discriminant of this quadratic. So b squared minus 4ac, which is minus 2 squared, minus 4 times by 2 times by 1. So that's the discriminant. That simplifies to 4 minus 8, which means that b squared minus 4ac, the discriminant, is equal to minus 4. Now, the consequence is if I was using the quadratic formula, I'd be having to square root that minus 4. You can't square root a minus number, and that's why you don't get any solutions. But from our point of view, all we have to do is say that the discriminant is negative, and therefore the line does not intersect the circle. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 34 and have a go at exercise 2D. Thank you very much for listening, and cheerio.